Hello everyone and welcome. My name is Eva Dace and I'm a member of the marketing team here at Vitech Corporation. I will be your host today during the webinar as Zane Scott and Jim Obermayer present Making the Business Case for Systems Engineering. Our program today is sponsored by Vitech Corporation, a 21-year-old company that offers model-based software and services. We are giving away 5 books today at the end of our program, so stay tuned. But before we get started, I would like to review a few technical details. First, questions. Please feel free to submit your questions at any time via the Q&A function in the GoToWebinar window. We will be monitoring these throughout today's event. We plan to respond to questions at the end of the webinar, so please stay tuned. Second, recording. The webinar is being recorded today. If you're having technical difficulties during the presentation, an online archive with this presentation will be available within 24 hours of the live version. Now let me introduce our presenters. Zane Scott is Vice President of Professional Services here at Vitech, where he leads the Consulting Services Department. He has taught in a variety of disciplines in college and professional classes. He's a trained hostage negotiator and interventional mediator and speaks often on communication and conflict management. Jim Obermayer is Vitech's VP of Business Development. Prior to joining Vitech, he was a principal of Sales Leakage Consulting, Inc. He has been a VP of Sales and Marketing at several software companies. He is an author and co-author of 4 books on sales and marketing and is a frequent speaker at industry events. Now I'm going to turn the mic over to Jim and Zane. Welcome and thank you both for joining us.
Thank you, Eva. It's a great day and we're looking forward to a nice program today. Again, our program is entitled Making the Business Case for Systems Engineering, but all these programs have a subtitle, and the subtitle for this one really is How Systems Engineering and MBSE Deliver Lower Risk Projects on Time and on Budget. Now for our program. This subject today really came out of a presentation at this year's GENESYS IS meeting in Philadelphia in June. And the program was the Business Case for Systems Engineering Study, Results of Systems Engineering Effectiveness Survey, of the Systems Engineering Survey by Elm and, Dennis Goldenson. So it's Joseph Elm and Dennis Goldenson at Carnegie Mellon University. Now, I was at that program, and so was Zane. The room was jammed up. We thought the air conditioning was bad, but it really wasn't that because the room was so crowded. People were standing all over the place. All the seats were taken, and everybody was fascinated by this program. This year in COSI, there were another 4 or 5 or 6 programs that addressed in varying degrees this same subject. How do I make the case for systems engineering and model-based systems engineering? Very interesting. We were just taken by this presentation by Joseph Elm. In the next 35 minutes, Zane Scott and I will discuss the SEI study, and I'll ask him some questions about SE best practices. We'll discuss how everything is driven by a model, whether the engineers know it or not. There's a lot of published evidence that those who use systems engineering and model-based systems engineering for projects produce better project performance. Zane, can you please share the highlights of this study, please?
Sure, I'd be glad to, Jim. The main thing that Joe's presentation and the study did for me, as I've read and reflected on it since in COSI, was to crystallize in my mind one of the essential difficulties that we all have. Everybody who practices systems engineering faces the task of helping our clients to understand how exactly what we do benefits them, how it becomes a linkage to their success. So how we get from the things that we do and the practices that we instantiate and use in our contracts to their ultimate success is a very important pathway for us to lay out. First, it's important for us to lay it out for ourselves, and then it's important for us to lay it out for our customers. This particular study and presentation helped me to realize that the answer to that question is really a two-legged answer, that there's 2 legs to that journey. Um, and the SEI study sums it up and links those two legs together and makes it possible for us to talk directly about client success out of the kinds of practices that we use. What SEI did in looking at this study was to look at a number of projects, and they looked at the projects from a variety of dimensions. They first looked at how successful the projects had been, and in doing that, they asked themselves several questions. The study looks at success as it's defined in terms of cost, schedule, and quality. And of course, this is the triad that we're all familiar with, and we've all become familiar with the folks who say that you can increase your efficiency in one of these areas, but it contracts your efficiency in other areas. Well, they looked at actual levels of success. They looked at programs and measured their success against all three of these propositions. They looked at budgetary success. They looked at the original budget estimates and the final cost of the project. They looked at other factors, the customer's satisfaction. The original budget estimates are typically that. They are estimates, and so sometimes the failure to meet those estimates, as well as the failure to meet the schedule estimates, are failures of the estimation as opposed to failures of the performance. But they graded performance against how well they met their budgetary projections. They also looked at the programs and said, how well did they meet their final deadline, and how well did they meet the intermediate deadline? So how well did they hit the milestone markers? And they used a number of factors in studying this. And then finally, the third criterion was the quality of what was produced. How was the quality in terms of its ultimate responsiveness to the customer's needs, to the stakeholders' needs? And they analyzed that as well. Now, they've detailed exactly how they did this. If you're interested in the statistical measures and the exact criterion and the exact questions they asked to get at it, I'm going to commend you all the way through this to the two papers that are on the SEI website that you can easily get a hold of. And one of them talks about the design of the study and the other one talks about the results. But in the design paper, they tell you how they decided what quality there was, how well it met the schedule, and how well it met the cost. Once they made an evaluation, then they did a statistical division and they grouped the projects into projects that had a high level, given these three factors, a high level of success, projects that had a medium level of success, and projects that had a low level of success. So they used these as the criterion by which they judged the ultimate project success. Then they looked at the projects for the maturity of their systems engineering practices. And for this, they turned basically to the CMMI type area of practices. And they issued questionnaires and they asked questions, and certainly, beyond the do you think you used a significant number of SE practices, they actually asked questions that were designed to test for not just the acknowledgement of the presence of some of these practices, but also the presence of the artifacts. And I think, if I recall properly, they looked for about 42 artifacts, and the 42 artifacts that they looked for in the work produced in these projects came from these 12 areas, came from these areas out of the CMMI.
If I can interrupt, now you mentioned
Sure.
CMMI. Can you explain that for people, what that means?
Yeah, the CMMI is the outgrowth of the original capability maturity model that SEI came up with in response to a government RFP. The government asked, surely there must be a way that we could look at an organization and determine how mature its practices are, so we can then predict whether or not it could actually handle the project that it's bidding on. That was the genesis of the capability maturity model. And these practices are all practices that are a part of that maturity model.
So what's on the screen here now, the requirements, development, management, risk management, these are the primary areas that they judged whether a project came in on time, at cost, and delivered the quality.
Well, actually, they independently said, was it on time, on budget, and deliver high quality?
Okay.
And then they said, okay, now that we've judged the relative success, we'll look at successful projects, medium successful projects, and projects with low success. And what we'll do is we'll look at them and see how many of these are present. How many of these systems engineering best practices are present in each of those types of, or each of those categories of the projects. And the thesis, of course, was what they were testing was that if you were mature in your practice of these 12 best practices, then you were more likely to have a high degree of success in the project. So they were actually looking at what emerged from the project to see if there was a correlation between a mature use of these practices.
And our contention, Zane, is if people are successful in these areas, this is really making the business case for systems engineering and model-based systems engineering, ultimately, which we'll talk about in a few moments. But let's go on with the research. I can't wait to see what the results were.
Yeah, let's talk about the results. Here's the overall result. This takes all of the practices in what they called an amalgam, and looks for the level of all 12 of the practices together in the projects and against the performance. So each one of these columns represents, the left column are all of those projects which had a low level of implementation of those 12 practices. The middle column is an accumulation of all of the projects that had a medium level of implementation of the practices. And the left column is the high level of implementation. Now, when you look in the study, if you're interested in the statistics, they lay it out. They tell you exactly how they tested the implementation. They used a 4-point rating scale, and they tell you the artifacts that they looked for to see if they were present, and how they rated individual practices, and how they rated the overall amalgam of the practices. So their methodology is laid out there for you if you want to take a look at it. But this is the end result of the whole amalgam of those 12 practices I just showed you. So if you look at the projects that had a low level of implementation of those practices, a low level of maturity, if you will, of the systems engineering, you find that 52% of those projects resulted in a low level of performance. Another 33 were able to achieve only a medium level of performance, and high performance was achieved in only 15% of the cases. Now, if you moved from the low level of implementation to the medium level of implementation and looked at the results in those projects, you find that 29% experienced a low level of success. So you see that 52% with the introduction of a medium level of systems engineering has declined to 29. The medium level of success is now 47% of the projects, but that total of the low and the medium you see there is still lower because 24% now experience a high level of project success.
Even a moderate improvement level in SE maturity in those areas bring a substantial bump.
Yeah, there's 9% increase, and even more than that if you consider both the medium and the high level. So yeah, you're increasing your success by increasing the level of your SE maturity. And if you go on and go up to the high level of implementation, if you get up to the area where we're talking about a real mature, robust systems engineering practice being present in the project, all of a sudden now you see that 56% of the projects, over half of the projects now experience a high performance level. And that's a flip-flop. So if you go from a low level of systems engineering implementation to a high level of systems engineering, you flip-flop low performance for high performance. So now over half of the projects experience a high performance. The medium level of performance takes you to 76%, a little over 3/4 of the project manage to stay out of the bottom tier here, or 80%, I guess. Sorry about
80%,
that.
Yeah.
If I'd been good at numbers, I'd have been a doctor.
Well, yeah. Well, that's why you were an attorney. So.
Right. So we've got now the low level of performance is confined to the bottom 20%.
Wow, what a shift! It's really
that's a big time shift.
I swear, in the room when they showed that, we heard some oohs and ahs, didn't we?
Mm-hmm. Sure did.
Yeah.
And then Joe went on to show us some more of the stuff they did. They took the individual practices and ran the individual practices against the success. And basically you saw this all the way through. The introduction of the individual practices brought on the higher success. And just like the introduction of the amalgam, the overall maturity. But one of the most interesting things that he had to say was he started talking about the fact that they recognized that in that group of projects that they studied, they had some projects which had a relatively low level of challenge, and some projects that had a high level of challenge. And by challenge, and they detail this in the study, and I'll leave that to you to pursue, but what they started to see was the complexity and the interactions and the constraints that were imposed, the external constraints that were imposed on the project, the things that made the project more challenging. And of course that's the world that most of us live in, is that more challenging, especially folks who are working in the DoD area and in very technical areas. You're talking about very complex projects. And so they reran this and they compared low to high. And if you look here, these are the results for high challenge. Now you see, if you have a low level of systems engineering implementation in a high challenge project, 69% of those experienced a low level of performance, and only 8% could achieve a high level of performance. So the complexity squeezes down on that high performance. It becomes much, much harder to get with a low level of systems engineering implementation. But if you introduce even a medium level of systems engineering maturity, you can almost triple it, or over triple, rather. So yeah, more than 3 times as many projects when you introduce a medium level of systems engineering practice more than 3 times the percentage of projects experience a high level of success. And look over here on the right. With a high level of systems engineering maturity, a high level of the instantiation and usage of those practices, a high level of the presence of those artifacts that show that you're actually using that systems engineering, correlates with 62%. Now, that's significant. So what it tells us is not only is there a correlation between your performance on a project and the maturity of your systems engineering practice, but that correlation is redoubled when you come back and you talk about high challenge projects that are complex and constrained and present a significant challenge. It becomes even more important to those projects than it was. So that 56% jumps to 62%.
That's really some significant numbers. Now, you've got some other thoughts on this, and then we've got some other studies that have come up that we can talk about this a little bit more. I see more people keep coming into the room as we go along. We're having an interview with Zane Scott, Vice President of Professional Services at Vitech Corporation, and he's addressing the subject of making the business case for systems engineering, and we're about partway through the program, but I keep seeing the numbers bump up a little bit every couple of minutes, so other people just keep coming in. This is being recorded, and you'll be able to hear the entire program next week. And if anybody has any questions, don't hesitate to start putting them in. Let's go on, Zane, and we'll see what the rest of this is and the other research and how this all kind of ties together in making this business case for MBSE and SE together.
Sure. One of the things that all of this made me realize was that when we're trying to help our customers, we're faced with, as I said at the outset, a two-legged journey. So this is one leg. If you can implement a mature systems engineering practice, then you can really leverage your customer's success. That's clear from what's here. So that's one leg of the study. The other leg of the study is something that we need to make individually. So we begin to think about this in terms of our own individual practices. How do we practice systems engineering? And this is where, for instance, for us, practicing model-based systems engineering with a single repository, single tool approach, we need to make a linkage from that to the systems engineering practice and start asking ourselves, how does this link up? Are we really promoting a mature systems engineering practice by what we do? And so the study, again, is helpful for us because we can drill back in there and look at those practices. And for instance, with requirements management, one of the most important aspects of the requirements management practice, as they describe it, is the bidirectional traceability, for example. So, are you able to trace your requirements through to your functional behavior, your logical architecture, and then on into your physical architecture? That's very important. That's a key to that systems engineering practice and a key to success. And so what we would say, for example, is that the model helps us to enforce the discipline of linking up the requirements to the behaviors, to the components, to the physical architecture. And therefore, our model is promoting that kind of practice. And so what we can say to a customer is, look, here's a study that says that if we do requirements management right, along with these other things, we can leverage project success for you. And here's how the way we do model-based systems engineering links to those practices. And so by using our approach, we can link you to the practices, which will then leverage the project success. And so now you have the two legs, the leg between our practice and the mature systems engineering that this study talks about, and then the study showing the linkage between mature systems engineering and the project success.
Now you mentioned something there. I don't want to get too far away from it. You mentioned both the single repository for information, but you also mentioned the model. Now, I know it's your contention that a model exists, why don't you explain it to everybody, that it's your belief that a model exists, whether it's in the mind's eye of the engineer or it's very public. How do you put that again?
Well, I think that all systems engineering in particular, but all engineering, all design is model-based. Mm-hmm. The issue is not whether or not you're using a model. The issue is where it is. Take for example, Michelangelo said that the way somebody asked him, how do you sculpt? And he said, well, what I do is I look at the rock. I look at the raw rock in front of me. And inside that rock, I see what's there. I see the statue. And so my job is just to chisel away the parts that aren't necessary. So I'm not really creating the statue as much as I'm freeing that statue from inside the rock. Well, now the only way for Michelangelo to do that is for him to have a model in his mind. When he looks at that rock and he sees that statue inside the rock that he's going to set free, he's using a model. He's using a mental model. Now, would I be much help to Michelangelo if he were going to sculpt a rock? I wouldn't be, number one, because I'm not skilled and my craftsmanship would not be good. But even if I were another great sculptor, I couldn't be much help to Michelangelo unless he could somehow surface his model and get me to see exactly what the model was too. And
so this comes back to that single database, that bedrock of knowledge, or is that right?
Yeah, that's where your model gets instantiated. That's where it gets surfaced and becomes accessible to everybody who's working on the design.
Well, there was I know there's another presentation at INCOSE, and there was another company, but pretty well known in the industry, and they made a presentation that they believe in model-based systems engineering, but they contend that you don't need a single database. They contended that, well, you could get the Visio stuff from over here and the micro stuff from over there and the requirements from over here, and you can put all this together and tack it all together. How can you possibly tack all of those different sources of databases together and make any sense out of it? It has to be a single version of the truth, doesn't it?
Well, yeah, I would take issue with them respectfully, of course, in a couple of different ways. One is it is possible. Of course, we see it done and believe that our methodology and our tools do it that way every day. So it is possible. And the second thing is that anytime you are exchanging data, you're moving your model around. The only way to do that is to communicate it. And when you communicate it, you have to first interpret and then communicate it. So the sender. So if you've constructed basically a model of the system in a requirements tool, so you have a requirements model, you've now got to communicate the requirements model on into the behavioral model. So you're having to exchange data. Probably the classic example of this is when you get ready to test. You've got a physical architecture team, and they've designed a physical architecture, and now they want to test it. So they're going to give it to the test team. Well, what happens is the physical architecture team has to describe their design. So they describe their design. Well, when they describe their design, they interpret the design and describe it and put it into a format that they can use to hand off to the test team. The test team receives that, and they look at what they've gotten, and they have to make an interpretation, and then they have to build something to test. So when they perform their test, are they testing what the physical architecture team designed? No. They're testing what they understood the physical architecture team to have described, which was what the physical architecture team interpreted their actual design to be for the purposes of the description. Then you become like a football team. The riskiest plays in football are plays that involve a number of exchanges of the football. So if you're going to do a triple reverse that ends with a wide receiver throwing a pass back to the quarterback or to another wide receiver downfield, you've gone through 3 or 4 ball exchanges, and those are 3 or 4 opportunities to fumble.
Yep.
Now you'll hear people say, "Oh, my tools all work together. They're designed to work together, and we use them together all the time, and we don't fumble." Well, that's kind of like a college coach going on ESPN and telling an interviewer, you know, "My guys play together, they practice together every day, we're all a part of the same team, we rehearse the plays, and we don't fumble."
Never fumble.
Yeah, okay. That's not a college coach with very much experience. Anytime you have to do an exchange, you risk the interpretation and you risk the fumble of the data. So if you're actually having everybody work through into the same repository, work through the same tool into the same repository, then you're all working on the same model. So you don't have 4 domain-specific models of your system design. You're working on one design. So that's how we would make that our leg of the argument that we're promoting those systems engineering. That practices. That would be a piece of our argument there.
So part of our business case is the single database, the ease of communications, the common language, and the constant updating of that database with all of the people looking at it. So it picks up efficiencies. It picks up ease of documentation. You don't have all these separate tools. You said earlier everybody says their tool communicates, and most of the time their tool works as they intend, but they don't always design the tool to actually communicate to other people. Now, what about other reports, other indicators? I know you've done a lot of looking into lean and what lean means in systems engineering and what have you. We've got a few minutes left. Can you share some of that?
Sure. I come from a process background, and over the years we've used a number of models of business practices and process improvement models, etc. And what you find is that the truth of the models is where they coalesce, where they come together, because they're all attempting to describe the same thing. So if you look at CMMI as a set of best practices, a set of systems engineering best practices, and then you look at lean engineering practices, they're at the root of it, they're trying to describe the same thing. They come at it in different ways. And there's a great study, a 2012 study that was put out, a joint effort of PMI and NCOSE and Carnegie Mellon's Software Engineering Institute and the Lean organization at MIT. And they put out a study called Lean Enablers for Managing Systems Engineering, I believe is the title. I've got a picture of it on down in the slide.
I picked up a copy in Rome at the NCOSE meeting in Rome last year, so there are some hard copies around, as well as electronic versions, aren't there?
Yeah, for instance, you can get that study, if you're an NCOSE member, you can get that study off of the NCOSE website. If you're a PMI member, you can pick it up through PMI in the PDF format.
So
But
this will pay for people just, if they're not NCOSE members, they ought to join just to get this study. This is a terrific study for considering the cost of NCOSE is almost pocket change.
yeah, and what you'll find when you open that up is the same kind of thing. They looked at projects. They looked at a number of government projects, and they looked at the correlation between how successful the projects were and the presence of lean enablers. So, and they kind of went at it in a little different way. They said, okay, we'll look at projects and we'll identify and categorize, and they built basically an ontology of problem areas. And then they correlated lean enablers with solving the problems represented in those problem areas. And so you could use this to track back. You could say, okay, I'm experiencing this impediment to my success, this problem area, and so I'll track that back into the lean enablers that are designed to address that. And that becomes a very valuable study. But don't forget that that's a two-legged answer as well, because what you really need to do is you really need to look at that with an eye towards saying, how do I do the things that I need to do to help those lean enablers be instantiated, to help the lean enablers become a part of the practice there.
Very, very interesting. But how does all this connect? Invariably, if somebody, or everybody has a model in their mind, or more officially, they follow a model. The tools that are available, it's the tool, the software, that really allows the implementation. So it's not only following good SE practices, right, and lean practices, it's also having that model which pulls everything together in that single database, and then actually having the tool, the software that pulls it all together to make it possible for everyone to work as a team and not all these separate little silos.
Yeah, and the other thing is that you need to recognize always that tools can never replace the basic thinking. The thinking and the real work of design is the work of the engineer. It's the work of the sculptor. It's the work of the artist. You can't replace that with a tool. So you can't point a tool at a problem and say sick 'em.
Yep.
But
yeah.
what you want
the tool doesn't do the thinking.
No. What you want the tool to do is you want the tool to help you manage the complexity. So as you think about this, you get it into the tool. I listened recently to a presentation by the guy who wrote Getting Things Done. And he said in that presentation, if I could get you to do one thing that would make you more successful and more productive, it would be to get you to get everything out of your head and into some kind of an instantiated form, whether you're using a handwritten form or a tool or whatever you're using. You need to get it out there and get it written down. And he said the reason is because all that stuff clutters up your brain and it doesn't leave you room for the creative work, and it can easily get forgotten because we're not a very good machine for handling lots of facts and information.
Was this a TED Talk?
Yeah, it was a TED Talk.
That is really interesting. I wanted to bring up something else as we're going along because, with all the budget cuts in Washington and budget problems and et cetera, people are going to think, well, we're going to have fewer projects, and we've seen some of that going on, but I think it's just temporary. Bloomberg just did a recording and a presentation, a couple of people there, on Secretary Hagel's interpretation of what's going on budget-wise, and they interpreted that, as usual, America will rely on technology because technology is a long-term advantage for us. We will rely on technology even though they're talking about reducing the force, 70,000 soldiers, 36,000 Marines, 5 air squadrons. And some of these things are going to reduce the overall force, but technology, they see the continued spending of dollars because technology is so hard to crank up. The force can be cranked up in 6 months to a year, but the technology can never be caught up for many, many years. So they were talking about this, and I look at it as it's more and more complex products that are coming on and are going to be coming on through the next 10 years. So while some people think, gee, a lot of our projects are going away or government spending is down, his indication was, in the technology side, we see this as a big advantage. And so I expect the technology spending will still be there, don't you?
Yeah, I think it's gonna still be there, and of course the complexity ramps up as you go from a kind of a brute force option to a technology option. That the complexity increases. So you're gonna see projects that are there, but you're gonna see something else that's very important. It's something that's kind of hiding behind the door in that analysis. And what's hiding behind the door is that those technology projects are going to be there, but there's going to be a huge emphasis on, guess what? Cost, schedule, and quality, because we can't afford to waste money. So the folks who are going to be able to profit from the technology projects that are there are the folks who can learn to correlate what they're doing with the systems engineering that leverages success. And the government's going to be looking for these high level of success projects. And here's the way to lay out the business case for that. Number one, do it. And number two, articulate it to your customer.
Now, we're lovers of MBSE, but can you tell the listeners how MBSE reduces frustration and disappointment in these complex product environments?
Well,
can you explain that a little bit more?
Yeah, the fundamental way, Jim, I think, is what we talked about, because the difference between model-based systems engineering and systems engineering that is not model-based is that we focus on the model, surface the model so that we all can see it and make it accessible. And so that means that now your complexity is being handled. Everybody sees where it is. So everybody has the opportunity to stand up and say, wait a minute, what about this? And we're able to manage complexity much better once we get the model out on the table and everybody knows what we're dealing with. The model of the problem and the model of the solution.
So we can do simulations earlier and more often through model-based systems engineering, right?
Yeah, and of course that goes to the particular way that we practice model-based systems engineering in a layered practice, but we begin at a very high level to develop the model and develop the model in a way that allows us to converge on a solution. So we're not finding ourselves climbing back up the tree and going out on a different branch to test something else.
One other question before we start to go to our questions in a few moments. I see a few more people have joined us again. This is the session, Making the Business Case for Systems Engineering. We're interviewing Zane Scott, who is our Vice President of Professional Services at Vitech Corporation. One other question: how does all this whole MBSE process and software and attitude reduce the overall project risk? Because that's really the business case, isn't it? It's the risk of money, it's the risk of time, it's the risk of quality. And if you can reduce these risks and produce your products on time, on budget, with less frustration, it's going to be a better life for the engineers who are all collaborating than people all working in their little silos. But what does it do for the risk equation?
Well, in the risk equation, take quality, for instance. There's a huge quality risk in that we will overlook an aspect of the problem, overlook an aspect of the solution, that we'll lose something, we'll lose a piece of the solution along the way, that we drop data, that we have to go and do rework. So the risk to quality is ameliorated by the fact that you have a tool there that's watching. The tool doesn't forget. If you put the tool in, if you put the information into the model, it's there in your model, and you want a tool that maintains that model so that when you go back, it's there, and it's not a matter of whether you and I even collectively can kind of remember what's going on. It's that we can put that into the model, and then we're free to work on it. So we reduce the risk that way. We better manage cost and schedule because we cut down on rework. We're not having to re-answer the same questions or try to figure out, now that we've made this change, how it impacts everything else that we've got in place.
Well, rework is a big deal. I heard a major West Coast, I was at an appointment a few weeks ago with a major West Coast supplier, I could say, and the rework issue was what they were really concentrating on. Rework, and they also were very interested in what we at Vitech call reuse, being able to actually reuse portions of the model and portions of the project for other projects.
Yeah, you don't want to spend lots of time revisiting the same questions. What my grandfather would have called skinning the same cat over and over again. Once you skin him, you want him to stay skinned, and that's reuse, rework. Reuse prevents rework. So yeah, that's a big factor.
Huge time saver. Well, we're kind of at the end here. I hope we've been talking with Zane Scott, Vice President of Professional Services, and I think we've really tackled this subject of the business case and making the business case, and how good systems engineering and MBSE deliver lower risk projects on time and on budget. I think we're going to have more in this series of discussions and interviews, possibly even with some people outside the company and other people in the industry that want to speak up and jump in on this subject. But I think we've got some time now to answer any questions that might have come up, and let's go on over to Eva, and Eva has some books to give away and some questions. Did you want any other words of wisdom before we go away, Zane?
No, not unless somebody has a question.
Okay, let's see what people have out there. Eva?
We've actually had some really great participation from our listeners today, and I just wanted to say I really appreciate that. So let's move on to the questions. My first one is from Andrew. He says, this single data repository you mentioned, does Core communicate with requirement software such as doors?
Yes, it does. In fact, Core 9 happens to have a brand new bridge to doors, a connector that allows you to move requirements in and out of doors, and that allows you to take the work that you've done in doors and put it into the Core database or the Core repository so that you've got that to work with.
And it goes to both ways, doesn't it, Zane?
Sure. You could also take it out of Core. You could take the work that you've done in Core and export it to doors if you needed a particular doors product or representation of it.
Well, when we were at NCOSI, I brought many of the IBM people over, and I invited them to come on over and look at that. And they were quite interested in it because they've got such a big market share in that one area, which is the requirements area. So they felt they seemed to feel very good about what we had done and our ability to connect. Other questions, Eva?
All right, moving right along, we have a question here from Henry. He wants to know if he needs Visio if he uses an MBSE product like Core.
It's funny. Henry wasn't here yesterday, but yesterday we had a webinar to talk about essentially how you use Core like Visio. You know, the appeal, the the marketing appeal for the tools that are basically drawing tools as opposed to large database repositories has been the ease of use. So are you able to quickly do drawings and to bring your thoughts to a visible form and to surface them, and they're good for that. You know, the drawing tools are good. But Core, especially in the Core 9 iteration now, has advanced its graphical interface to the point where you can draw in Core essentially like you're drawing in Visio or the other drawing tools. The difference is that Core retains the powerful back end. So as you're drawing in the graphical front end, Core is preserving all of that in the back end. So for instance, you can drag and draw in an EFFBD in Core, and then if you want an activity diagram, it's not now time to redraw the diagram as an activity diagram. You just click on the tab and there's the activity diagram.
It's already drawn. Right.
Yeah, and oh, by the way, we have an n-squared diagram and a sequence diagram, and all of those things are there because Core is pulling the information into the repository and then can feed it back out in a number of views. So
it not only makes all of these drawings all at one time and relates them all, but what happens when you make a change in one drawing? Do you have to go back through all the other drawings?
No. If you introduce an element in an activity diagram and go to an n-squared diagram, there it is.
I love asking that question because I know the answer, but I still like asking it.
It is fun. It is fun to ask that question.
Do we have any other questions today?
We have a lot of other questions. Macaulay asks, are these results due to MBSE practice or generally for documentation based on systems engineering? It sounds like when he asked the question, the results part was referring to a specific thing. So I guess, Macaulay, if you could get back to us in the questions pane and specify what you meant by that, we can move on to the next question and we'll get back to this one. Okay. Harold asks, are there any learning points of the study for complex operations like oil and gas industry?
Yeah, I think the study has application, and one of the biggest learning points is the more complex, like the oil and gas stuff that you're talking about, the more complex it is, the more important that you have the discipline of the systems engineering practices. Because as the problem becomes more and more complex, it becomes more and more necessary to keep track of it in a disciplined way. So yeah, I think it has applications there. It has applications in any kind of a system, and certainly the oil and gas delivery and drilling systems and all of those refineries, all of those are systems within the purview of this stuff.
Well, not to put too fine a point on it, but there have been some real horror stories out of the oil and gas industry in the last year or so of them trying to implement complex programs and projects and apparently failing in the process. And MBSE would have probably solved those issues and given them, at the very least, a lot of cover that they had actually followed best practices. Don't you think?
I think you would want, from a legal standpoint, to limit your liability by getting the best possible solution that you can get, and then B, by being able to say, you know, I did all of the things that that someone using best practices could possibly do. So in constructing the system, you get better success and fewer problems on the ground, and you have a better justification for where you are and how you got there.
Okay.
Okay, thank you for that. Next question is from Richard. He asked, did SEI conduct the survey for software systems only or for mixed technology systems?
I believe, and this is detailed in the study, but I believe that they were mixed technology, that they weren't just software.
All right. Kristen wants to know, can a tool help find design emissions?
Yeah, you have, for instance, in CORE, which is of course the one we're best familiar with, we have what we call consistency and completeness checkers. So if you don't have an allocation made, if you don't have a relationship set, if you have attempted to set up a relationship, for instance, if you're trying to allocate a function to more than one component, the tool is set up to spot that and to bring that to your attention. So CORE, for instance, has the consistency checkers and completeness checkers that are designed specifically for that, and you have a diagnostics tab available to you right in the element properties page that you can click on and go right to and access those checks.
Does that come up as a warning? Does it come up as a pop-up? Are there reports for the?
It comes up in different ways depending upon what we're talking about. If you try to do something that doesn't make sense to the tool, it tells you on the spot. Other things come up when you run the consistency checker after you've done some work.
Very nice. We're coming up on the hour. Eva, any other questions?
Well, I was actually just going to ask you guys, we have a couple more good ones. Are you all okay with staying just a little bit longer?
I'm okay with it, Zane, and people can either stay on or drop off, but we are giving away those books when we finish off the last question. So go ahead.
That's right. Okay, so our next question is from Mark. He wants to know, how effective can MBSE methods be in helping a company look at scenarios based on future technologies? In other words, helping us get ready for a technology or design that hasn't been invented yet.
I think, right, and I think one of the most powerful things that MBSE can do is that you can model the context. And lots of times people forget that. But you can not only model this, what we call the system of interest, the one you're going to design, the one that's right in front of you, or your particular project, but you could go and model the context system. So you could put in what you know about the context and then look at it and see if there's a technology in the future, here's what the interfaces are going to look like, and here's how it's going to have to fit. And if you go in this direction, it causes waves that go in that direction. And the more complex, the better the bigger the advantage that the tools and methods would give you. So yeah, I think that'd be an exciting use of it, and something that would be really interesting.
Okay.
All right. Let's go back to Macaulay's question. He was asking originally, are these results due to MBSE practice or generally for documentation based on systems engineering? And he came back to us to clarify. He said, I was talking about the SEI study results. Are these results possible without the MBSE leg?
The results would be possible, I suppose, but again, what happens is if you're document based, so let's say you had all of the artifacts and all of the practices present and you had big stacks of documents, theoretically you could achieve that performance, but not as easily because you can't test the ramifications in a model, and you'd be susceptible to introducing contradictions, to introducing inconsistencies. You don't have a way to manage it and have the same assurances that you would with model-based. And again, remember, I'm suggesting there's no such thing as systems engineering that's model-based. The question is whether the model's in Zane's head or in Zane's system.
Okay.
All right, let's go ahead and do one last question from Joseph, if that's all right with you.
Yes, yes.
All right, he wants to know, does CORE provide diagrams that can be translated into the UML? i.e., does CORE do the translation from EFFBD to UML?
And that's an answer that's kind of beyond my ken. I don't know if I've got, we can get back to you with that one. Joseph, I can have one of the engineers answer that.
All right. Well, thank you both. That wraps up the Q&A for today. If we didn't answer your question today, we apologize, and we will contact you directly to ensure that your question has been answered. If you have any other questions or comments that you thought of later, you didn't send them in today, we invite you to post them on the forum of our community site at community.vitechcorp.com. And as I mentioned before, a recording of today's webinar will be posted in the resources section of our website by the close of business tomorrow. So in closing, I'd like to thank all of you for joining us today. At the conclusion of this webinar, a survey will open on your screen, either in a new browser tab or in a new window. Please take a moment to provide us with feedback on today's presentation or on what topics you'd like to see covered in future webinars. Once again, thank you for joining us, and have a wonderful day.